All right, today we're going to be looking at section 4.5. This is the prep for rational exponents. I'm going to take you through the book this time just to kind of start and show you some properties and things that would help you if you go in and write those down. So this is in chapter 4. If you open up the e-textbook, it takes you directly to that page, and all you have to do is scroll up and down and you have all the information. So you have the objectives here. I'm just going to kind of go through these definitions and the boxes before we get started. So first, it's showing you the definition of a rational exponent. You could have 1 over that, a denominator, or a numerator and the denominator, some numerator other than 1, that is. So it just shows you m and n are integers, they're whole numbers. Whatever the root you're using, that's going to be the denominator of the rational exponent. Can I zoom in? It seems like it's kind of hard to see. There we go. It's still a little fuzzy, but 1 divided by n is an exponent in the rational expression, is the same thing as taking the nth root, okay, of that value. And the same if you had a m divided by n, okay, whatever's on the bottom, the n is the root, m is the power that you're going to raise that number to. And you'll see that in practice. Here they're giving you an example, 16 to the 3/4 power. The 4 is the root, 3 is the power. You can do them in any order is what it's showing you here. If you want, you can take the 4th root first and get 2, and then raise 2 to the 3rd power, you get 8. Or you can cube it first. You can raise it to the 3rd power first, you get 4096. And then you take the 4th root, and that gives you 8. So here are just some examples of evaluating, and they show you the solutions hereafter if you want to use some of those to practice. Again, you got several of them here that they show you some examples that you can click on and see different powers. Shows you how to use it in technology. So if you have a graphing calculator or some scientific calculator, you can enter this information like so, and then it will output the solutions for you if it's a whole number. Even if it's a decimal, it'll give you something. Again, several more examples. The next part, we want to convert between rational exponents and radical notation. So this is going back and forth between writing it as a rational exponent versus writing it as a radical. So again, these are some examples, and then these are solutions that they let you practice on. I'm going to scroll through, so several of them. Simplifying expressions with rational exponents. So these are the properties of exponents that you definitely need to remember. Jot these down, put them in your notes so that you can know what steps to take and what each property does. So if you're multiplying 2 exponential terms with the same base, you add the exponents. Dividing 2 exponential terms with the same base, you subtract. Raising an exponential term to another power, you multiply. And then if you have 2 factors being multiplied raised to power, it's the same as distributing that power to both. It's only when it's multiplication that does not work with addition. Okay, so be careful there. With division, same thing. You give both of them that power, and then negative exponents, you can rewrite it as a rational expression. So a negative power just writes that divisor or the base as a rational expression. 0 exponent is going to be equal to 1, and then you have some examples to the side. So this is pretty much going to be the general overview of what we're going to be looking at here in chapter 4.5 for rational exponents. Majority, the rest of the section is going to be going over some examples that give you some problems, show you the solution, sort of work it out, give you some applications when we actually do some word problems. But as far as learning what to do with it, that's most of the meat up there. You can factor also with polynomials. Remember, factoring, add or subtract it. You just subtract those exponents and The rest, you just get a lot of different examples. So all of this is examples and practice problems that you can use as extra practice. So with that said, we're going to jump into Aleks and start our section.